Welcome to Learn Yourself. Today we are going to understand the solve example 10.1 and this is under CBSE Standard 10 syllabus from the chapter Light, Reflection and Refraction. So this example says that a convex mirror used for rear view on an automobile has radius of curvature 3 meter. So this is our convex lens and this I have showed here the Cartesian sign. And if you have any doubt regarding the mirror formula, magnification formula and Cartesian sign, then you can please refer my video based on mirror formula and magnification formula. I have given the link in the description. And then come back to this numerical. So here when it is towards the left side, image or object, when we are checking the distance of image and object is towards the left side, then it always comes in negative. When they are towards the right side, then it always comes positive. So here they are saying that the radius of curvature is 3 meter. So radius of curvature is r and that is 3 meter. If bus is located at 5 meter, now bus is our object and that is located at 5 meter from the mirror. So here this is convex mirror, as they said here that this is convex mirror. This is a convex mirror and its reflecting surface is this. Its reflecting surface is this. So whatever object we are locating, its distance will be towards the left hand side. Is distance towards the left hand side, because here if there is an object, for example from the rear view mirror we are locating the bus. So bus has to be towards this side. Then only we can see its reflection into the mirror. So bus has to be towards the left hand side. So the distance we are marking, that is into the negative. Again, this is a convex mirror. This is its reflecting surface and object we are getting it towards left side because this is a mirror and here we can see the reflection of the bus which is coming at the back. So here we are checking. So this is left side. So that's why we are marking this distance in negative. So distance of object is u and that is 5 meter. That is 5 meter and that I am marking in negative because that will be towards the negative side. That bus is towards the negative side because it is towards the left side and according to the Cartesian sign, this distance will be negative. So that's why I have marked here negative. Now, we have to find the position, nature and size of the image. Position means where we will get the image. Nature means whether it is real or virtual, and size means whether it will be big or small. So all these things we are going to check from the mirror formula and magnification formula. So first we need to find out V and F. So F is a focal length. Focal length is a distance between pole P and focus point. So that is our focal length. So that we are going to find out from the R. They have given here R. So R is radius of curvature and formula is R equals to 2F. Now we know R. So from that we can find out F. So F equals to R divided by 2. We know R is 3. So 3 divided by 2 we will get 1.5 meter. We will get 1.5 meter. And this distance is going to be positive. Why? Because this is a convex mirror and focus point of the mirror is going to lie behind the mirror and that is towards the positive side. That is towards the positive side. So this length, distance between pole P and focus point is known as focal length. And it is going to lie behind the mirror because this is convex mirror. So this distance, that focal length is going to be positive. That is 1.5 meter. Now we know focal length and we know the distance of object. From that we can find out the distance of image. Now our mirror formula is 1 divided by V plus 1 divided by U equals to 1 divided by F is there. We do not know V but we know U and F. So from that we can find out distance of image. So 1 divided by F minus 1 divided by U will be our formula for this numerical. So let us put all the values that F is 1.5 then minus u is already minus, that is minus 5. That is minus 5. Now once we will solve this, we will get 5 minus 1.5 in division with 7.5. Now this is already minus and this is also minus. So this is going to be plus. This is going to be plus. So it is 6.5 divided by 7.5. So we are going to get here 1.15 meter, and that is V. So our V is plus. Our V is plus, and that is 1.15. So this plus suggests that it will be towards the right hand side, and it is virtual image. It is virtual image. Now we are going to find out the magnification. So magnification formula is m equals to minus v by u. M equals to minus v by u. We know that what is v. V is distance of image. V is distance of image, that is plus. That is 1.15. That is 1.15. So it is plus 1.15. It is plus, and the u is 5. So that is minus. This is plus and this is minus, and again this minus sign we will get it from this formula. Again this minus sign we are getting from the formula. So this is going to be plus. This is going to be plus because minus minus will be plus. From where this minus has come? This minus has come from here, because this is distance of object. So that is already minus, and this minus is from our formula. So this minus and this minus is going to be plus here, and answer is 0.23. So magnification is 0.23, and that too positive. That too positive. Now these are two answers from the mirror formula and magnification formula. Now let us understand that how to interpret these answers from Cartesian sign convention. So from our calculation we got this two answer, that distance of image is plus 1.15 meter and magnification is plus 0.23. So now first of all, position. How to check the position? So that we will get it from the distance of image. If this sign is positive, then we will get it at back of the mirror. Then we will get it at back of the mirror or towards the right side. This is a convex mirror, so we will say that we will get image towards the back of mirror. Why? Because this sign is positive. So from where we will find out the position? From the sign of the distance of image. This is not suggesting us that where will be its position. Its sign will suggest us that where will be its position. If the sign is negative, then it is towards here. If sign is positive, then it is towards here. This is suggesting exact location, that at this location we will get the image. But we required whether towards this side, towards the left hand side, in front of the mirror or back of the mirror. So that we will get it from the sign. So whenever we are getting positive or negative sign from the image distance, that sign is important for the location of the position. So here this is positive, that means we will get it at back side of the mirror. We will get it at back side of the mirror. Or you can write towards the right side, but the exact word is towards the back side because this is convex mirror. Now comes to nature and size. So nature and size, both these things we can find out from the magnification. We can find out from the magnification. In answer of magnification, one will be sign and one will be the number. So from sign, it is positive. When magnification answer is positive, then we will get the virtual image. Then we will get the virtual image. If this is a positive, then it is a virtual. If this is negative, then image will be real. Then image will be real. Now comes to size. So if the number is in a point, it is less than 1, then size is smaller than the object. Then image size will be smaller than the object. If size is 1, if here we are getting 1, then image will be equal to the object, then size of the image will be equal to the size of the object if it is 1. And if it is more than 1, then it is bigger than the object. Image will be bigger than the object. Magnification itself suggests us that how much larger the image will be. If it is in point, if it is in 0 point something, then it is smaller than the object. If it is bigger than 1, then it is bigger than the object. And if it is 1, that means the size of object is equal to size of image. So here this is plus, so that means it is virtual image. And here the answer is 0.23. So it will be smaller by a factor. It will be smaller by a factor of 23. That is how we will write. And so that is how we will interpret our answer. One answer from the sign of the distance of the image, and then two things, nature and size, that we will get it from the magnification. So first you have to check the sign and then you have to check the answer.